parallel plate capacitor. It has uniform electric field E in the space between the plates. So the parallel plate capacitor, when it is connected across a potential difference V, okay, the charge on both the plates developed is plus Q and minus Q. And this is how the configuration is. So it is like plus Q on the inner side and minus Q on the inner side. Okay, and outside it's 0 and here also it's 0. This is the detailed configuration of the charges. Okay, detailed distribution of the charges which are there on the parallel plate capacitor. Now in a parallel plate capacitor, the assumption is that D is very much less than the length or the height of the plate. Okay, so since it is very less, so therefore we take each plate to be kind of an infinite sheet. Okay, D is very less than area. Okay, so therefore we take it to be an infinite sheet, and thus we apply the formula of the electric field due to an infinite sheet. Okay, and therefore the formula comes out to be, so from here it comes out to be sigma by 2 epsilon naught. Okay, now what is sigma? Sigma is the charge density, which is Q, like whatever the charge has been accumulated, so Q divided by A. Okay, so just kind of to summarize whatever we have discussed till now. So plus Q and minus Q is the charge present, and therefore the charge density becomes sigma. Sigma is equal to Q upon A, and due to this sigma, the electric field in between the plates becomes sigma by 2 epsilon naught, electric field from the positive charge, positive sigma, and sigma by 2 epsilon naught from the negative sigma, and both are in the same direction, so therefore they add up. So therefore ultimately the electric field is sigma by epsilon naught. Okay, this has to be remembered. So here also we have this electric field. So this electric field is basically sigma by epsilon naught, which is basically Q divided by A epsilon naught. Now the distance between the area plates is D, area is A. Energy is stored in the capacitor. So energy stored in the capacitor will be so let us use this formula, Q square upon 2C. So energy stored is Q square upon 2C. Now this is the electric field. So we can substitute Q as A epsilon naught into E. So therefore this becomes A epsilon naught. So A square epsilon naught square E square by 2C. And what is the capacitance of a parallel plate capacitor? Epsilon naught A by D. Epsilon naught A by D. So D goes up. So epsilon naught is gone. A is gone. So therefore there is half E square epsilon naught A into D. Okay, so this is wrong, this is wrong, this is correct, and this is also wrong. So therefore the answer is going to be C. Again I summarize. The electric field is sigma upon epsilon naught. Sigma is Q divided by A, so Q by A epsilon naught. Okay, and this electric field, okay, is given. the value is given. So we have to express everything in terms of the electric field. So since this value is given, so therefore we express Q in terms of E, and that's what we have done. So Q has been expressed in terms of E, okay, here, and Q square divided by 2C. So we do this, we get the result. Thank you.